type "Plan my trip to Paris" into a chatbot. You want a completed itinerary, flights booked, and hotel reservations secured. Instead, you get a polite bulleted to-do list telling you exactly how to go do all of that work yourself. That happens because current large language models are essentially reactive text generators. They live entirely within the vacuum of a single chat session. They take a discrete input, run it through a neural network, and spit out a predicted output. Once that response is generated, the process stops. The model has no persistent memory and no way to actually go execute the tasks it just described. The AI is acting as a passive brainstorming partner. The burden of orchestrating the steps, fixing errors, and finalizing the bookings sits right back on the human user. Autonomous AI agents completely change that dynamic. These are cognitive entities designed to perceive their environment, reason through complex strategies, and adapt their behavior based on the feedback they receive. To understand how to actually construct these systems, we look to Imran Ahmad's 30 Agents Every AI Engineer Must Build. It is a technical guide to engineering this next generation of artificial intelligence. For decades, software development has relied on procedural code, humans writing explicit, step-by-step instructions for a computer to follow. Now, we are designing systems that are given a goal and then independently determine the behavior required to achieve it. This represents a move towards goal-directed behavior, shifting the logic of the software from following static pathways to making decisions under uncertainty. It mimics the architectural transition from procedural to object-oriented programming by treating the AI as an independent, interacting entity. To achieve that level of autonomy, the software system needs a structural framework that mirrors the way humans approach problem-solving. This sense, model, plan, act loop is the cognitive backbone for decision-making. Notice the continuous outer ring cycling from perceiving through acting, circling a core objective. At the top is the sense and model phase, where the agent gathers context and builds a persistent internal map of its environment. If an AI lacks this dynamically updated internal world model, it remains blind to the context around it, making long-term strategic execution impossible. Let's apply this architecture to our earlier scenario. You give an autonomous travel agent the objective, book a trip to Paris. This chart outlines execution. In the plan phase, the agent checks memory and decomposes the objective into smaller tasks, like checking visa requirements. In the lower act phase, it bridges internal logic with the external world, utilizing tools to execute the sequence. This flowchart shows exactly how that tool usage works. The agent uses a universal interface layer to discover and invoke the right external APIs, like flight aggregators and hotel databases, without needing a developer to hard-code every single custom integration. This dynamic tool orchestration makes the agent an active digital worker, handling the specific technical handshakes and data formatting that usually require manual human effort. But the real world is unpredictable. What happens if the flight API times out, or the hotel you wanted is suddenly fully booked? Traditional deterministic software struggles here. Following strict conditional logic, a missing variable or broken link results in an error code that halts the entire application. This diagram illustrates handling failure. During the reflection phase feedback loop, the agent registers that the outcome deviated from its goal and updates its internal state. It then dynamically replans, independently searching for alternatives and adjusting flight times to ensure the high-level goal is met. This ability to continuously analyze outcomes, recognize failures, and correct course without human intervention is the true benchmark of computational autonomy. By combining persistent memory with external tool usage and dynamic replanning, agents are taking over highly complex, multi-step operations across industries. We are seeing these systems deployed today to resolve enterprise customer support tickets or adjust supply chain logistics when shipping constraints suddenly change. In massive distribution centers, multi-agent systems are coordinating fleets of delivery robots in real time, instantly adjusting routes to maintain maximum efficiency. As these agents handle the execution, human workers move from doing the manual labor to supervising and directing strategy. It is an architecture designed to amplify human intelligence. The demand for software engineers who can build these robust, stateful systems is surging. Prompt engineering is a start, But architecting true autonomy is the next technical hurdle. To learn how to bridge that gap, pick up a copy of Imran Ahmad's 30 Agents Every AI Engineer Must Build, available now on Amazon and Pact. And to keep exploring the deep architecture behind the next generation of AI, subscribe to neurals.ca.